Good morning and welcome everyone. In today's class, what we are going to do is that first of all, we'll solve some questions on the previous chapter, that is radiation, and some questions that are left for practice. So we would be doing that. In the previous class, we had discussed Stephen's law and Wein's law. We had seen that if we increase the temperature of a body, the energy it emits increases. It is proportional to the emissive power is proportional to T raised to the power 4. The total emissive power is proportional to T raised to the power 4, whereas the spectral emissive power is proportional to T raised to the power 5. Yes or no? Do we remember this? Okay. Then we had also seen that when the temperature increases, the radiation, which has got the maximum energy, the wavelength of that radiation, it decreases, or lambda max is inversely proportional to temperature, and this law, or lambda m into T, is a constant, and this law becomes your Wein's displacement law. Every body is emitting radiations. We don't see them because their energy is very small and it lies in the infrared range. If you heat something up enough, you'll start seeing it. You'll start seeing the radiation, red hot, orange hot, yellow hot, and so on. I hope you remember this. You have gone through this, and I hope you have tried some problems from the what? From the sheet that I had given you. Have you tried problems from there or not? And I hope that you have found that most of the problems that you might have encountered, they would have come from the theory that we have discussed. That is why we have discussed theory in details. Anyways, it's my humble duty to present more problems, which I find that they can come maybe exactly same in the examination hall. And here is the first one for today. The lambda m, oh, this is not lambda m, this is mu m. That means the maximum frequency. Maximum frequency T curve for a perfect black body is, which one is the lambda, not lambda, frequency temperature curve for a perfect black body? May I have your answers, please? I hope you remember how we had drawn the curve. I had shown you the curves. Can you now tell me which one is the curve? It's just a revision of what we had done in the class yesterday. And I hope that you are not going to let me down on this. So which is the answer? What is the answer? Not which. What is the answer? Question number 84. This is question number 84. Taken from your sheet. Yes, bacha. And I hope that you don't get -5 on this. You should get +4 on this. Yes. I can't see it. 2. B. Yes, I can see it in big zoom. Well, that is how you use technology to your advantage. That is the correct answer. Answer is definitely B. Frequency is directly proportional to temperature. This is one of the tougher questions that has come, because normally you will not find the graph between lambda and T. Please remember this. Do you understand this? Can I move further ahead in life with the next question? Remember that what? That whatever question, remember my words, out of the 50, you have to solve I mean, you will get choice in 10 questions. You have to only solve 5. Remember, out of the 50 or 45 questions, whatever way you look at it, most of the question, somewhere around 30 to 32 to 35, 30 to 35 questions would be based on simple knowledge. You know it, you take it, you know it, you take it, you know it, you take it. You have to solve 45 questions in a span of less than an hour. So all the questions, very less questions would be going to be of numerical nature, and one or two would be tough where you will have to solve a lot of numerical. Otherwise, most of the question 30 to 35, and that is what we are aiming for. Those 30 to 35 questions, even if you don't solve any numerical, you should be able to crack them. If you're able to crack them, you will score somewhere in the range of 110 to 120, depending on how many are wrong. And that is a good score in physics. That is what we are aiming at. And from 5 to 7 questions will be simply just put the formula, get the answer. If you can get those 5 to 7 questions wrong, you will be solving somewhere around 35 to 40 questions. If you get to around 35 to 40 questions, you have done exceedingly well in the exam. Please remember that. This is the next one that comes in line. There is a black spot on the body. The body is heated, carried in a dark room. Then it glows more. This can be explained on the basis of A, B, C, D. Question number 93. And the answer is 2. Wein's law. Why Wein's law? Why Wein's law? Black, 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 black spot is treated like a black body. So it will absorb more, it will emit more. Which law tells you that? And the answer is Kirchhoff's law. It absorbs more, it's a perfect absorber, it's a perfect emitter. So when you see it in the dark, it will be emitting the maximum, and that is why you see it glowing. Do we understand this? Yes or no? No, yes. Can I have some reason that we understand this? So these are the things that you must remember. This is how you apply theory and get answer from that theory. Again, the numerical which you can expect in this chapter would be somewhere of this nature. Even can't call it numerical. This is again based on your understanding of or your remembrance of Stephen's law or whatever we have done. Question number 95 from your sheet. A black body is a temperature of 500 Kelvin. It emits energy at a rate which is proportional to. It's a straightforward question. I can't see your hands, but I assume that you are saying it is number 1, 500 raised to the power 4. The only thing they could have done is that instead of Kelvin, they could have written degree Celsius, and then the answer would be 773 Kelvin. Do we understand this? Remember, it is proportional to absolute temperature raised to the power 4 and nothing else. Don't get confused or don't make a stupid mistake, because a stupid mistake will cost you -5 rather than +4. From where I see my maths is somewhat different. I see a difference of 9 marks from one question. That is absolutely rubbish. It's -5. According to Newton's laws of cooling, next question, the rate of cooling of a body is proportional to, as you can see, questions are pretty damn simple. Temperature of the body, temperature of the surrounding, fourth law of the temperature of the body, difference of the body, difference of the temperature of the body and its surrounding. And the correct option is temperature of the surrounding, number 2. No. The correct option is difference of the temperature of the body. Do we understand this? Newton laws of cooling? Yes or no? No, yes. Okay. Now comes a numerical, and I hope that you can open. Okay, where is my this thing? You can you would be able to solve this numerical, and here it comes. Jipmar 2003. A cup of tea cools from 80 to 60 in 1 minute. The ambient temperature is 30. In cooling from 60 to 50, how much time it will take? And you have your options done. Now looking at the options, if you don't have time to solve it, and some people call it trick, this is not trick, this is just applying what you know. Looking at the options, are there any options which can be voted out, vetoed out, that these cannot be the correct options? Anyone can tell me without solving anything, which options are absolutely rubbish? They cannot happen. Which options are absolutely rubbish? They cannot happen. Any idea which options are not possible? Option number 1 is not possible. It cannot cool faster than it was cooling before. Yes or no? Option number C is also not possible because it cannot cool in the same time for 10 degrees Celsius, because the rate of cooling will go down. So there are only two options which are possible. So if you don't have any time left to calculate and you have to guess, now it's a 50-50 probability. 0.5 is the probability, 50% the chance. Either it is 90 seconds or it is 48 seconds. These are the only two options that are possible. So if you have to guess and you cannot calculate the value, you can obviously guess out of 90 and 48, someone would be the answer. 48 cannot also be the answer because 48 is also less than 1 minute. It cannot cool faster than 1 minute. Yes or no? So the only possible option is, see, I have not calculated anything. I've just marked the option as 90 seconds. And if you are calculating it, that means you have not understood the question. Looking at the option, sometimes you can mark the answer without even solving the question. Do we understand this? Everyone in the class, do we understand how I have done this without even doing anything? Just understanding that Newton's laws of cooling tell us that it is proportional to the difference in temperature. In the first minute, it cools down by 10 degrees Celsius. To cool it again by 10 degrees Celsius, the time would be more than 1 minute. There's only one option which is more than 1 minute, and the answer is 90. There's no other option. If there was any other option, then you could have calculated. Otherwise, it is not required. Shall I move ahead in life? Do we understand how it is done? Raise hands will give me more confidence. Okay, here comes the next one. Question number 105. Two black bodies, Kali bodies of absolute temperature to 1000 Kelvin and 3000 Kelvin, respectively. Then the ratio of wavelength corresponding to maximum emitted energy would be in what ratio? Their absolute temperatures are in the ratio of 2000 is to 3000, 2 is to 3. What will be the ratio of their wavelengths of maximum energy? And this is a straightforward question from which law? The law is known as Wein's displacement law. Can I have your answers, please? Question number 105. And the correct option is option. There are only two options possible. C and D are already voted out, vetoed out. It is not proportional to T square. So 2 and 3 are voted out. Lambda m is inversely proportional to temperature. Do we remember this? Temperatures are in the ratio 2:3. So the ratio must be ulta. So this option goes away. And the answer is 3:2. Are we getting this or not? Yes or no? No or yes? Shall we move on to the next question? Okay, let's see. Can you apply some common sense? And with that common sense, can you tell me? Obviously, you can calculate and tell me as well. But looking at the question, a body cools from 60 to 50 in 10 minutes. Room temperature is 25. Assuming Newton laws of cooling holds good, what is the temperature at the end of next 10 minutes? Now, looking at the question, can you vote out some options that, sir, these are not possible? Are there any options which are not possible? Well, if you can't think which options are not possible, I would suggest that you solve the question and you get your answers. That is not a problem. But you can very well say which options are not possible. In 10 minutes, it has cooled down by 10 degrees Celsius. In the next 10 minutes, it cannot cool by 10 degrees Celsius or it cannot cool by more than 10 degrees Celsius. Yes or no? So the only options are which are possible are A and B. Now, if you don't have time to calculate, you can play Kaun Banega Crorepati. This is 50-50. Two options are already on. Now you can guess. And probably if your guess is correct, if you don't have time, remember. Your guess is correct, you will get +4. If your guess is wrong, you will get -5, not -1. Okay. But obviously you can solve it. Now I leave it to you to solve it and tell me the answer. I will give you a minute to do this. Have you got the answer, bacha? Okay. How to do this? 60 to 50. It required 10 minutes. And I have to find out how much it will go in the next 10 minutes. Next 10 minutes, let us say the temperature is theta. Do we understand this? What do? I make the equation for this one. theta 1, 60 minus 50 divided by 10 will be equal to k times theta 1 plus theta 2, 60 plus 50 is 110 divided by 2 plus the, oh sorry, plus or minus, minus, no? Making a mistake here. Minus the ambient temperature is 25. Do we understand this? Then I make the equation for this one. How does the equation for this one look like? 50 minus theta divided by 10 is equal to K into what will be the average temperature? This will be equal to 50 plus theta divided by 2 minus 25. Do we understand this? We just divide now. So 60 minus 50 is 10. 10 divided by 10 divided by 50 minus theta divided by 10. I can cancel this 10. Will be equal to, this is 55 minus 25. 55 minus 25 I think is 30. 30 divided by 50 plus theta by 2 minus 25. You just need to calculate this. How do you calculate this? This goes here, this goes here. So this is a problem that will take some amount of your time, to solve it, and you will get the value of theta. Now, do you have that much of time in the examination, or you might not have? So you can make an intelligent guess. How do I make an intelligent guess? Do you understand how to solve this? Yes or no? The only thing is, this is just a part of maths and it might consume some time. It might consume some time on your end. So you can just make an intelligent guess if you want to. And the intelligent guess is, in 10 minutes, it cools down by 10 degrees Celsius. In the next 10 minutes, it will be slightly less than the 10 degrees Celsius that we have seen. So you can look for the nearest option, and the nearest option that you can see here, which I suppose is option number B, because looking at the equation also, you will not get 45 degrees as your answer. You can also do one thing in the equation. You can put, since you have only two options, I will give you one more shortcut to do this. Instead of solving for theta, the equation in theta was looking very confusing. Yes or no? It would take a lot of time. It would take a lot of time. It would take a lot of time. It would take a lot of time to solve it. Instead of solving it, out of these two quantities, 45 and 42.85, you can put the value of one quantity and see if the equation is correct. 42.85 would be difficult to put, so you can just put 45 degrees and see whether the equation is becoming true. What do I mean when I say this? Now, these are the ways in which you can get to an answer without actually finding out the answer. I hope everyone is listening to me. Yes or no? Okay. So what I'm telling you here is, instead of solving it on this step, I think we had reached this step where we had this calculation, right? We had reached this step. Yes or no? Now instead of solving this, because for equation of theta, it might be difficult for you to solve. It might take, not difficult, it might take a lot of time for you to solve it. So what do you do instead of solving it? I call it reverse engineering. Use the answer and get to the question. I have only two answers which are correct. Either it is 45 or it is 42.85. Point I don't like, so I will just choose 45. If the equation is good for 45, the answer is 45. If it is not good for 45, the answer is 42.85. Do we understand this? Now, instead of getting into calculated, I just rub this off. And I'm just trying to get to the answer. Somehow, I want to get to the answer. Now, how do I somehow get to the answer? Two options are already wrong. Two options are correct. Out of those two options, I am using one option. Now, look at this equation, which is equation number 1. From equation number 1, I can get the value of k. This is 10, this is 10, so this is 1. 1 is equal to k into 30. Yes or no? So my k ka value becomes 1 by 30. Yes or no? Okay, k ka value is 1 by 30. Now instead of solving this, what I do is instead of theta here, I put 45. So this equation becomes 50 minus 45 divided by 10 should be equal to k into 50 plus 45 is 95. 95 divided by 2 minus 25. Do you understand what I've done here? I put one of the answers in the question. Right. So this is 5 divided by 10, which is 1 divided by 2. This will be equal to k into 95 by 2 is how much? 95 by 2 is, I think, 47.5. Yes or no? 47.5 minus 25. Now see, this value of k and this value of k should come same. Yes or no? Are they coming same? They will not come same because this will be, this minus this will be 22.5. 22.5 multiplied by 2 is 45. So probably from here I will get the value of k as 1 by 45. Yes or no? From 1 I am getting the value of k as 1 by 30. From the other equation I am getting the value of k as 1 by 45. So obviously whatever I have put in equation number 2 is not correct. So 45 cannot be the correct answer. Only the correct answer that is possible is 42.85 or whatever option. Do you understand how I have, instead of solving for theta, I have put the value of theta and got to the answer? Obviously, you cannot do this if all the 4 options are possible, because if all the 4 options are possible, you have to put 1, then put 2, then put the third one, and if your kismat is kharab, all those 3 options would be wrong and the remaining option, so you have to do it the same exercise 3 times. You may not be able to do this. So in those cases, it is easier for you to solve this equation. In cases where you just have 2 options, you can just put the option, one of the options in the question and see whether the question is coming true or not. You may not have to solve it. You can get the answer by this small trick. Do we understand this trick? Now this trick I have done it for this question, but you can do it for any question that comes. If you have voted out some options, you don't know some options are not possible, only 1 or 2 options are possible, you can use this trick. Use one of the options in the equation and see if the equation is coming correct or not. Can we move further ahead in life? Yes or no? No or yes? Okay, that takes me to the next question. And the next question is this one. The original temperature of a black body, Kali body, is 727 degrees Celsius. Calculate the temperature at which this black body total radiation or radiant energy becomes double. So I want this body to emit 2 times the amount of energy it was radiating. What would be the temperature of this body? The time starts. So, do we have the answer, bacha? Two, three, four. What? Kajal is saying three. Everyone is playing Kaun Banega Crorepati. How to do this? How to do this? So, the original temperature is given as 727 degrees Celsius. The first thing is that we convert it into kelvins. Yes or no? So it will be 1000 kelvins. Correct? So at 1000 kelvins, you have some energy. I want this energy to be doubled. Now remember, energy is proportional to T raised to the power 4. This is the original energy. 2E. Energy becomes twice. So what will be the temperature? So I can write this equation in this fashion that water like this. T2 by T1 initial temperature by final temperature would be E2 by E1 raised to the power of 1 by 4. Do we understand this? Fourth root. Yes, my dear friends. This one is 1000. So I just multiply it by 1000. E2, the final energy is twice. So this ratio will become 2. Yes or no? Yes or no? So it is 2 ka fourth root multiplied by 1000. Now you may not know what is 2 ka fourth root, but you can use common sense and give me the answer. You can use common sense and give me the answer. The first option is obviously wrong because it cannot be less than 1000 Kelvin. Yes or no? The only options which are possible are B, D, and C. C is 2 times of 1000. 2 times of 1000 is not possible. So this option goes away. Yes or no? Now we only are left with 2 options. Now look at this 1, 4, 5, 8. If I take the root of 2 is 1.414. Yes or no? So if it was root of 2, the answer would be somewhere around 1400. But it is not root of 2. It is root of 2. 2 raised to the power 1 by 4. That means this option is already gone. The only possible option is option number 2, 1190 Kelvin. You understand? Without finding out the fourth root of 2, we were able to find out the answer for this one. How I've done this? Looking at the option, I've done this. If the option would have been very close, then the problem would have come, but that question will not come to you because they are not testing your ability to find the fourth root of 2. They are testing your ability whether you can use your brains or not. Can I move further ahead in life? 1 or 2 more questions. We are almost to the end of this series of questions. So we will wind it off with the last few questions that are remaining. I think we are on the last page literally. And this is the next one. A perfectly black body is the one where A, B, C, and D. Can I have your answers, please? And the option is number 4. The absorptive power is 1. That is a perfectly black body. Let us now move on to this one of the most difficult PMTs in India, Rajasthan PMT, RPMT. Temperature of our sun is 6050 Kelvin. And the emitted wavelength is 4753 Armstrong unit. Oh my God. If the emitted wavelength by a star is 9506 Kelvin, Armstrong unit, what would the temperature be like? Oh. Calculations. Let's see who gets me this. I'll give you a minute to win it. Where are my kids? Did you get the answer? No? See, the problem with you people is you don't use your brain. You don't use your brain. Because you could have used your brain, bacha. The answer was right in front of your eyes without even doing anything. Without even doing anything, the answer was right in front of your eyes, beta. Kaise? How? What law you will have to apply here? Yes, the answer is 2. Without looking anywhere, answer is 2. You will have to apply in such questions. Lambda m into t is constant. Which law am I talking about? I am talking about Wein's law. Yes or no? Do we understand this? The product of lambda, wavelength, and temperature T is constant. Product of lambda and temperature T is constant, or lambda is inversely proportional to temperature. Now look at the values here given in the question. Look at the options. Open your eyes and look at the options before solving the question. Bacha, open your eyes and look at the options. Temperature is 6000 Kelvin. The wavelength is 4000 something. Now the wavelength has increased. Wavelength has increased. So what will happen to the temperature? Temperature will decrease. There's only one option where the temperature is less. Tongue, 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 and the answer is this. Don't have to calculate it. And see how much time you have saved. I have saved a lot of time just marking out. Do we understand how this is done, or it has gone about ahead saying bye 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 bye? I am going bye 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 bye. Do we understand this? Now, the next thing is, what if there was other option who was also there? Now, in that case, you might have to calculate it. But again, when you are calculating it, remember, 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 they are not checking your calculation skills. They are checking whether you have brains or not. Now, they have given all sorts of fancy numbers, 4,753, 9,506. Don't you have to use all those correct values to get to the option which is the correct answer? Instead of using this wavelength as 4,753, you can simply use it at 4,750. Or if the options are very varied, you can even use 4,700 and your answer will come approximately very same. Instead of using this 9,506, you can simply use 9,500. Now you can put this formula and get the answer. Your answer will come somewhere close to 3,025 Kelvin. You don't have to do exact calculation. You can use round off values. You can use the closest value, which makes your calculation simpler. Instead of using 6,050, you can also use 6,000. The answer will not vary that much, and you will get a very near answer. Do we understand this? So if it comes to solving the question, do not use exact values, just use approximate values, get to the answer, move on in life, move on to the next question. They are not checking your calculation skill, they are checking whether you have brains or not. A doctor without brains is a very difficult concept to understand. Oh, do we understand this? The screen was paused, so you could not see what I was doing. Instead of 4,753, you could use 4,750 or even 4,700. Instead of 6,050, you could have used 6,000 and still got the very approximate answer. Do we understand this? Let us see if you can apply some magic here in this question. This is question number 109 from your sheet. And just looking at the options, you should be able to tell me, bacha, which is the correct option. Which is the correct option here in question number 109? Without even solving it. Do I have answers here? Or I only have questions in the mind? No answers? No idea? Get idea. No answers, get the answer. No one has an answer. And the answer is C. There is only one answer that is possible here. 200 Kelvin, 1000 Kelvin, temperature has increased, wavelength has to decrease. Only one option has a lesser wavelength, and that is the correct option. You don't have to solve it. You don't have to solve it. Do we understand this? So that is how you use some common sense and get to the correct option. We are getting to the end of this chapter, literally, the exercise as well. Here comes a question. The spectrum from a black body radiation is dung nung, A, B, C, D, 1, 2, 3, 4. And the correct option is option number 3. It is a continuous spectrum. It has all the possible wavelengths that it emits radiation of all possible wavelengths. Let us see who can get me the answer to this one. RPMT 2005. A piece of steel is heated to 100 degrees Celsius. Is allowed to cool in a room. Which of the graph is correct? A, B, C, D, 1, 2, 3, 4. You heat it up, putting on a heater or a burner. Then it will cool down using Newton's laws of cooling. So which is the correct option? A, B, C, D. And the answer is A. Yes or no? No or yes? Okay, so see, questions that are going to come in the examination hall are going to be pretty simple, and we are done with all the questions that were possible. I think we are done. Just one more to wind the things off, because I always wind things off with the conceptual question, and let's see whether you can do this question here. A body takes 3 minutes to cool from 62 to 61. Now, this is not a question from PMT, it's a question from P. Let's see if you can apply some common sense. This is the most difficult question that I think can come. That body takes 3 minutes to cool from 62 to 61. Surrounding temperature is 30. The time taken by the body to cool from 46 to 45.5 is how much? Obviously, you can solve this question, but if you do it, try to which options can be correct. One of the options is definitely wrong. Which one of the option is definitely wrong? Or yeah, are any options wrong? Remember, here the fall in temperature is 1 degree. Here the fall in temperature is half degree. So that is the difference. That is why you may not be able to guess such questions, and it might take you actual solving to get to that question, because all the 4 options may be possible. The only option that may not be possible, which you can guess, is probably equal to T by 2 minutes. But again, it will be difficult for you to solve such question just by giving a logic. So in that case, you will have to solve the question. How will you solve the question? You will make the equation and then you will put the value. Do you understand this? It will just be a calculation. It will just be a problem that you will have to solve by calculation. If you don't have time, you can move ahead. If you think that there are options that you can avoid, you can make a intelligent guess. Do we understand this? So I leave this question as an exercise, and I hope that you can move on with this. Now what I'll do is, since we have come to the end of this chapter, I will give you 5 minutes, 5 minutes of your time, and go through this entire chapter in totality. See if there's anything that is troubling you, then tell me. So I will go back to that topic, back to that subtopic, and clear your doubts. So I'll give you 5 minutes. Please go through the entire exercise, entire chapter. If there's anything that you have not understood, please let me know. 5 minutes, it's what you get. So with this, we have come to an end of this chapter, and we will start with optics.